Hello everyone, it's July 17th. Alright, take a look here. Nothing of concern. No, I don't think that's not mine. I don't have the space in between. Alright, let's do this. 3 equal parts. Array, zeros and ones. 3 non-empty parts. All of these parts represents the same binary value. If it is possible, return any ij with I plus 1 smaller than j such that blah 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 to I is the first part, I to this is the second part, and then j to the end is the third part. All 3 parts have equal binary values. If it is not possible, return this. The entire part is used by considering that binary values represent. For example, only 0 represents 6 in decimal, not 3. Leading zeros are allowed. So this and this represents the same value. So we're going to split array into 3 non-empty parts such that all of these parts represent the same binary value. Okay, so this one, so 0 to, oh yeah, so 0 to 0, that's the first one, and 1 to 2, 1, 0, 1, 2, 1 to 2, and 3 to the end. These all represent 1. This is not possible. And this is 0, 0, and then the second part is actually 1. Third part is 0, 0, 1. Okay? I think I understand what the question is asking about. So we need to split into 3 parts and then return I and j. So I is the limit of the first one. J is the start of the third one, right? So j is the start of the third one, and then whatever is in between is the second part. And has to be I mean, I and j, they go into both sides, go to either side. So everything I or before, everything j or after. So the stupid way is we go, I is the first, right? I has to point to the first, and we can point j because all 3 has to be non-empty. So j has to, so I start with 0, j starts with 2, right? And then we compute, see what we have. And if it's not good, j keep moving. So j moving all the way to the end. Whenever we find something, and then we check the middle. We find something, check the middle, and it's no good. So 1 round, and then I move 1 forward, and j moving again. I move 1 forward, j moving again. Now, that is going to take O(n). I mean, when j goes all the way, right, and I can actually compute, right? I can compute what it is. So it's actually, so when I is the first position, j, I can actually go from the end to the front. I think if I can know any position, right? If I know any position, that'll be very helpful, right? That'll be very, very helpful. This seems to me I'm going to say segment tree, but it's like a prefix sum. But it's not exactly prefix sum, because the value changes, right? The value changes. Because as I grows, And the middle, you have to recompute the middle. Right? The middle is different every single time. But in one run, it's not different. Is it? It's like for given any I, if I compute I, we move I forward, the computation for the next one is easy. Right? The computation of the next one, I won't say it's easy. It's like shift, right? It's just left shift 1 and plus whatever is 1 or 0, right? Yeah, so that one is simple. And for I is simple. J, if we know the J and we shift, that's just like it's like it's not a left shift, right? And it's not right shift. It's cut it off. I cut it off, which is fine. It's also doable. I can do that. But 3 times 10 to the 4th, that's going to be a huge value. So maybe string will be an easier way to handle the situation. Yeah, I think string will be easier so we can avoid a lot of computation. We can compare string directly. Okay, so J, we have all the string values from J position, right? From J position all the way down. So at each position we already know. Just compute it once. We know all the values. So like from here, from any position to the end. Any position to the end. So whenever in the future we want a J, we can go immediately and go for it. Yeah, we can get all the possible J's, right? All the possible third part we can get. All possible third part we can get. And it's also possible that we can also put them into a dictionary so we know the positions, right? We know their positions. That's for J. That's good. And that's going to take ON to compute all the J's. Now we can also compute all the I's, right? We'll compute all the I's. We can go one by one. Like we get first I, and then we look for J if there's any J that's in the list. If it's not, we just keep moving, right? Until we find one that we have the J, and then the middle, we compute the middle, right? And then we keep moving, keep moving, keep moving, keep moving, keep moving J, keep moving I, right? So we keep moving I, and we compute the J already. So we have all possible J's, and we keep moving I. At each I position, we know the string. And actually the next string we can just append to it, and it's fine, right? And it's fine. It's a 0, we just append to it. If it's not 0, we append 1. So it's fine for I. And for each I, for each first part, we look into the J dictionary to see if there are any possibilities. Now once we find the possibilities, then we go look into the middle part, right? We'll look into the middle part. And when we look into the middle part, we just, I'm not sure. It didn't say like there are like one solution, or if it is same banner, if it is possible, return any. So any. So we just find one, and that's fine, right? We just need to find one. Let's give it a shot. Let's give it a shot. My timeout. If it times out, I have actually other responsibility today. So if it times out, we're gonna go look for the actual solution. So I don't have too much time. So let's get this one done. Hopefully fast. Yeah, let's try this idea. So the ideal is we're gonna do a dict j, right? That's gonna be this, and we say we're adding more to the right, so each one will be different. Each one is unique. If you think about it, every one is unique. Starting from the, like if it's a 0, oh, the leading zeros. Yeah, because j has to start from here, right? J start from here. If it's a 0, then that's nothing. We just keep going until we don't find a 0. We'll find the first one that's not 0. Because anything else, it will be 0. That's not going to work. But find the first one that's not 0, and then everybody will be the same. So we're first going to skip any zeros. So j is equal to, what's the size? 3, 0, 1, 2. So it can be 2, right? And say while array j is equal to 0, j plus equal 1. So we skip until the first j that's not 0, right? And then we say while j smaller than array, len array minus 1. No, len array, right? I can actually put it here, n equals len array. I might use len again. So we say smaller than n. Say current j equals nothing, right? And then current j plus equal to str array j, and dict j current j. Yeah, you're always adding, so it's all different. It's all different. This one equal to j, right? And then j plus equal 1. In this case, we can actually just say, that's fine, j plus equal 1, right? That's a while loop. We go through every single one, keep adding, and then keep pushing this in. Now, we don't really need to have a dictionary. No, we do need to have a dictionary because it's a reverse mapping. So we have to have a dictionary. So we store everything for j. Now we know all the j positions. Now we're going to look in the I, right? So we say I, for I in range, I going to be from 0 all the way to the last I is going to be this, right? So that's n minus 1 minus 2, n minus 2. So I going to be all the way to n minus 2. Hold on. No. J have to go the other way. We're removing. That's not true. We're removing. What you're doing is wrong. We're removing. We have to go from the other end to the front. So this is correct. It's not like it's the end, right? End, j end, then here, and j end. Sorry, I got it backwards. This is 1, and then 0, 1, and then 1, 0, 1. Then we have the repeats, right? Then we have the repeats. Like this is 0, 1, because we are adding to the front. We're not adding to the back. We're adding to the back. Oh, I is adding to the back. I is adding to the back. That's interesting. I is adding to the back. So all i's are unique. J's are not unique, but all i's are unique. Yeah, because I is here, I is here. Every time we add a new thing to I. So we shall reverse it. We shall do I instead of doing j. Yeah, I is unique. Leading zeros are allowed, but it represents something different. Trailing zeros have to be counted, right? Let's understand. So we should go I to the first I, because that will just represent the same. These will just be zeros. We do need to, I mean, it could be 0. Right? It could be 0. So how should we do this? It should be I. It's not J. It's not J. Because J, every time we add new things to it, it's slightly different. It's I. Okay, change idea. I gonna be 0, right? And then for array I is 0, I gonna be plus equal to 1, right? Now I is landing the first non-zero part, and now we have to also add I. It could be 0, right? So it's not dict J, it's dict I. So in this case, we're gonna say if I is larger than 0, that means we have skipped 0, right? So we say if I is larger than 0, then we say dict I dict I 0, right? We use this equal to I minus 1, right? So we skip all the zeros, all the leading zeros. Don't really mean anything to us, because for I, if I land in any range of this, it's all going to be discarded, and for the middle part, it's going to be not counted as well. So if I is larger than 0, which means we have skipped some zeros, we have to include the zeros back. So we include the 0 back. And then this, now we're going to do current I. We're going to say start with this, right? And then while I is smaller than what? So the end of I is going to be here. We said it's n minus 2. So n minus 2, right? That's the end. It's n minus 1, n minus 2, right? N minus 2. Smaller than n minus 2 is actually n minus 3. Yeah? So smaller than n minus 2, actually, that's a smaller equal to n minus 3. And current I plus equal to I, because we're adding more to the end. And if we add, it's always going to be unique. And then dict I, current I is equal to I, right? And then I plus equal to 1. So we create the entirety of all possible i's. Now we're gonna do j. So j gonna start from n minus 1, right? J start from n minus 1, and j start from n minus 1 and will end at this position. That's 0, 1, 2, ni2. But I cannot end I2, so I have end I1, and then I'll go 1 less and end here, minus 1. So this is all possible j's, right? All possible j's. And then I'm going to start just adding, right? We're just add to it. So we're going to say current j equals nothing, right? And then we say current j equals to str array j plus current j, right? Plus current j. That's the new string. But it depends. Like if the current one we're adding to it is a 0, right? If it's a 0, then it doesn't mean anything, right? That doesn't mean anything. So we say if the current one is not 0, if it's 0, then we just don't change it, right? We'll just say if array j is not 0, then we do this. Then we add a new to it. Otherwise, we don't add. But we still have to check at each j position, right? So array j is this. Now, we say if current j is in dict I, That means we find one in dict I, right? We find one in dict I is in dict I, then we can find the I position, right? When we find the I position, let's just use I again because we don't use I anymore after this. I would just say, just dict I current J, right? Now we obtain the I, and I think Python has a left strip. We probably need left strip. Python string left strip. I think it does have left strip. Wait, is that strip has left or right? No, we don't want trim. L strip. L strip. Yeah, I think it's L strip. All leading white spaces. Oh, all leading white spaces. Oh, strip. Oh, I can type this, removing special character. Given set of character. You know what? I want to try it before I use this left strip. So what I'm saying is, if I have this, right, and I say ake.l strip, param cat chars equals to 0. So on the left strip, takes no keyword. Okay, that's not a keyword. Yeah, it does strip all the zeros. So I think it works. So now I find it, right? So if it's in there, then mid shall equal to, man, this is gonna be expensive though. Right? This is gonna be expensive. Array. If we do a splicing, and a join, this is where we are going to possibly time out. If you think about it, right? If you think about it, if there are like better ways to handle this middle situation, I fear it's going to time out. Let's try it first, right? So the most naive way is we have the middle part, and we have the middle part. For the middle part, have we partially calculated already? If you think about it, right? We have partially calculated. Yes, we have. We have partially, because when we go through I, right? When we go through I have every single possibility, right? So I have this, I have this, I have this, I have this, all the way until the end. This one is not, and this is J. And I have everything. I have everything computed, right? So I should utilize that. I shall utilize that, which means now I give me a certain J. So this is a certain J, right? And I find out some I is matching. Now the question is the ones in the middle, what is the value? I mean, I know this value. I know this value. I also know this value, right? So what we want to calculate is this value minus this value left shift. That will be the middle value. Yes, that is going to work. So what we're trying to do is not using string specifically. We're going to be using numbers, right? When using numbers, and dict I, we still need it. We still need dict I, but we're gonna have two things. So one is dict I, right? And the other one, we have another one. Think about it, we have another one. Is the value at each position, right? At each position, what is the value? It's just this thing, left shift 1 and plus a value, right? Left shift 1 plus a value. Yes, left shift 1 and plus a value. So, no, let's scrap that. Let's scrap that. So it's going to be values. So vals, right? Vals I is going to be a list, right? It's going to be a list. And then what we're going to do is for I in range, I can all the way go to n minus 2. We know that. And what we're going to do is saying, actually, this one is going to be array 0. So put 1 there, and this is going to be for 1 to this, right? And we say vals I dot append, right? Dot append what? Vals I minus 1, the previous one. We're going to left shift 1, and plus array I, right? And I'm going to make sure that we have the parentheses. Now we do this for everything, then we have the full value. Now we have the full value. But meanwhile, we do also need a, whatchamacallit, the dict I, because the dict I allows us a O1 finding. Therefore, we're going to say current V, current val, equals to this, right? So it's current val equals this. And this one, we're going to append current val and dict I, current val equals to I, right? So we go through this to populate both. Once we populate it, none of these are needed. Come on, none of these are needed. So this is to populate the front. Now we're going to go from the back. And again, when we go from the back, it's different. We're going to say val j equals the last value, array minus 1, right? It's an array minus 1. And then what we're going to do is, okay, no, I don't think this is the right way. So, but for this, it's going to be plus this one left shift j. So yeah, current is 0, right? So going to be for this equals for range n minus 1 is the last one, n minus 1, and all the way to the front, right? All the way to 1, because we want to land it at 2, right? So that's cool. And then every time val j, how do we calculate val j? So val j shall equal to what? The current array j, left shift, right? Current array j, we're gonna left shift how many times? Left shift n minus 1 minus j times, right? Which means at the beginning, it's going to be left shift 0 times. If left shift 0 times should be the value itself, right? Like for left shift 1 is going to be times 2, but left shift 0 is going to be itself, because we're not shifting, right? We're not shifting. So when the left shift that bunch of times, right? We have to put another parentheses, and after shifting, we're going to add val j, right? Add val j. So that's the first val j. And then we're going to say if val j is in dict I, now that's when we look for the indices, right? So it's in dict I. Now after it's in dict I, oh, but there is an issue. The value can be huge. We're talking about the length is 3 times 10 to the 4th. That is going to be problematic. 3 times 10 to the 4th. That is a lot. That is a lot. I don't know. 3 times 10 to the 4th. Can we even do that? 1 left shift 1000. It's 3, 1, 2, 3, 4. 3 times 10 to the 4th. Oh. Huh. We can. Huh. But I feel like it's going to be... Oh, let's try it. If it's too slow, we'll figure something out. Maybe, we mod? We can mod. We can mod. Like 10 to the 9th divided by 10, like that modding might work. But let's try this idea first. So yeah, we compute all of that, and then mid. What do you call it? K. Let's be the indices, right? K. Oh, we're actually going to be mid. Right? Going to be mid. So val j and dict I, we find they're the same, and the mid is going to be val I, right? It's going to be vals I what? J minus 1, right? Vals I j minus 1 minus vals I dict I val j. That's the I value, right? That's the I value. But it's not directly doing this. It's this thing we have to left shift, right? This is the value we have to left shift. How many times? How many times have to left shift? It's going to left shift. So here is j. Here is I, right? So in this case, I is 2, j is 5. So it's a shift j minus I minus 1. So it's going to be here, shift j minus I minus 1. That many times. So we go this, right? And minus whatever is the previous, right? And then once it's done, it's a mid, is going to equal to this, right? Val j minus 1 and vals this left shift that many times, and then we find the difference. That's the mid, and we say if mid equals val j, then we return, right? What do we return? We then return. I do not like that. Let's just talk. I equals to, yeah, this is I equals to this, and it's going to be, no, I does not equal to this. I equals dict I val j, and here is going to be vals I, and if it's good, it's going to return I and j, right? I and j. If not, I keep going. So j keep going, one by one, one by one, one by one. Keep getting bigger, getting bigger, getting bigger. Man, at a certain point, we shall be able to escape earlier. Because every time j goes forward, the potential, like for I, like the maximum I, so we can have the maximum I, right? Initially the maximum, yeah, so it's going to be like this, right? So val j, if val j is larger than vals I j minus 2, that's like at any time j, the largest value you can get for I is j minus 2, right? So if any time the j value is larger than the I value, the largest possible I value, then we should escape, because it's not going to happen. Because the j is only gets bigger and I is only gets smaller, so it's less and less likely that we will have certain I value. right? Yeah, so like the j value is too big. The j value is larger than the current largest I value. Then no other I value can match. Then that's when we call it. We say it's not happening. So we say that's gonna break. And this one we're gonna return -1 and -1. All right. I have confidence, but I am also pretty worried that this is going to either time out because the computation, the time is just too much, or it's going to say memory like out of overflow, something like that. But we're gonna give it a shot, at least on the test case, and see if the logic is sound. That's 0. The answer is 0 and 2. Oh, the answer I return might be something different. But I think these have only unique answers. 0, yeah, this is unique answers. Yeah, these are unique answers. Array, it's going to be 3 equal parts. Check it. Current I is not defined. There's no current I because it's called current val. It's called current val. All right. Ooh, that is not correct. That's fine. These algorithms never works the first time. So what we're gonna do is, step by step, we're gonna check the vals I, right? All right, the vals I. Let's see if it's correct. So we're looking for the vals I it's 1 0 1 0 1. So we're looking for 1. 1 0 will be 2. 1 0 1 will be 5. And then that's it. 1 2 5. That is correct. That is correct. And then we need to also print. Let's also print dict I. We don't have 0. We don't have 1 there. Why is that? Because I forgot to add it here. Array 0, 0, right? Index out of range. So 1 is a 0 position, 2 is a 1 position, 5 and 2. That's correct. So the problem is mid. Which one index out of range? So we do find, so let's do this. We do find, right? Let's print I and val j. So I is 0, val j is 1. That's correct. How about j? J is 4. 0, 1, 2, 3, 4. That is also correct. J is 4, right? And then vals I, J4, that's 3. Vals I, 3. But vals I doesn't have 3. Have you thought about that? I does not have 3. It does not. And this is not -1. I see. I see. Because it doesn't have, because I does not end at that position. But that's fine. We can just do one more, right? We can just do one more. So instead of, I can go here. If I go here, then this one can pass. Oh, I just do a little bit more, then we shall pass. And these two, they all pass. Oh, nervous. Let's see. Pending, judging, Wrong answer. Let's just take a look. Wrong answer. Output 3 and 4. 0, 1, 2, 3. 3 and 4. That's not correct. That is not correct. I mean, this one can be anything, right? Anything, just not 3 and 4. So we're talking about 0 and 4. Okay, so that is because I see the problem. So it has to be, I has to be this, but now it's out of range. But this, right? This. So what we need is it doesn't have j minus 1. Hold on. So I still want to include everything, but in here, if I have to do if this dict I dot get I equals dict I dot get val j minus 1, right? I'm going to say if I is larger or equal to 0 and 0 I and smaller or equal to n minus 3. That's the I range. Then we do this. Now the last one we have issues. I think it's because, I don't know, the last one. Let's take a look at the last one. The last one shouldn't be surprising because dict I and vals I, vals 0, 3, 0, 1, 2, 0, 1, 0, 1, 0, 1, 2, 3. Why would you go 3? Doesn't make any sense. I doesn't reach 3. Oh, it does. 0, 1, 2, 3. So we end up here. So that means good point. Good point. Let's concentrate on. Let's take the smallest, right? Don't take the large one. I'll take the smallest, because if we take the smallest, and everything it will switch to the smallest, and the other ones it does not matter, right? It does not matter. I think you should take the smallest, which means this one shall equal to min dict I current val. I just say if dot append dot get current val I, right? And get this one, we're just gonna say math.inf. So we want the smallest. So for math, this one pass. Okay, before we move on, let's see if we pass anything else. Oh, we passed 115 out of 118. This actually looks promising now. It looks promising, very promising. All right, try it again. Pending, judging. We got accepted. We got accepted. Thank you very much, my love. Wow, I am surprised. Okay, it's a very terrible runtime though. Only 7% ranking. we got accepted at 1200 milliseconds, and the top one is 400. But that doesn't matter. We got accepted. Very, very happy. Very happy that our first attempt got accepted. After a few fixes to handle the leading zero issues, right? So the idea is to create a prefix sum-ish array for but that's all. I know that it is possible for us to use binary search because this is an array and they're always increasing. So we can use binary search each time. So instead of calling a dict, right? Instead of calling a dict, we can go binary search. But binary search that requires this one be log n here. So on, and this will be on log n. Right? And we don't want on log n, right? We don't want on log n. This one is on. I mean, technically speaking, two ons, and then it's on. So no, that is not the issue. I think the issue is just with the computation of the big numbers, the big values. So we're gonna try using a mod, right? See if it's gonna get any faster. So we say idea is to create a prefix sum array for the first element, all right? And then we start from the end of the array and gradually create the third element. For each third element, we check whether the same value has appeared in the first and in all possible first elements. If we can find such first element, we obtain its index and use prefix sum magic to compute the value of the second element directly. This technically runs in on, but the left shift operation can add up as the list size gets big. That is, we are handling giant numbers, which is not really possible if you're using like C or Java. You probably have to use a different library, like a big int library to handle this. But technically, it's on. It is on technically. So we had 12, right? 12 millisecond, 1200 millisecond, or 7% ranking. I think this is considered a hard problem. It should be, it's fine, right? All right, so now we're gonna do an update. What I think we're gonna do a mod. 10 to the 9th plus 7, which is usually used in LeetCode. So with this mod, current value, every current value, we're gonna mod, right? We're gonna mod. Append, git, blah 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 blah, and then the J is the same thing. Every value we are going to mod. But this Even if you mod it, it's gonna be problem. It's going to be problem. Ah, I see. It's going to be binary. No. Let's try mod first, and then we're talking about binary, so we can use like plus, and we can use and or. Maybe those are faster. Let's try mod first. If mod doesn't get us faster, or mod is wrong, then we just don't use mod. We switch to the other idea. And we have this early breakage. But in this sense, does early breakage even work? Yes, it does work. I think it does work. Early breakage does work. No, it actually does not. No, I don't think it works. Mod. Because if we are modding, then this part doesn't work. No, I don't think it's mod. I think, yeah, because you're saying that, no, mod times 2. I think all operations. Hold on. No, mod doesn't work because plus minus doesn't matter. Mod will always work. But multiply, but when multiply, this is a giant prime number. That's a giant prime number. Does multiplication change the mod? Oh, this looks good for so far. So the size, I don't know. When mod a value, right, and then it becomes small, become tiny. Like when it gets bigger, we can become tiny, and then I think this idea will. I don't know, man. I don't know. This idea might not work. No, I don't like mod. Mod doesn't seem to be the right way. No. If not mod, are we talking about we are doing this add? Every time we add something, we kind of go back into the old way, right? But still, I don't see like how it can be like what, just and, like or. We can like just say, instead of this, we say or, right? This or this, we add one, and this should be fine. And then here is this one left shift, right? And is that or? We're trying to add the two values. I think it's add, it's not or. That's not or. Yeah, I think add is fine. I don't think add is the problem. Maybe it's minus. I mean, with a shift, and then this one minus, it could be this one or this thing. But these are giant values. This is a giant number. This is a giant number. It's two giant numbers. But we can always or them. No, it's not or. It's exclusive or. This one is exclusive or. Exclusive or. How about this? So, no, val j is a big value. This is a big value. So we have oh, this is also exclusive. This is or because it was shifting, right? So the initial value not initial value, is the current j. We shift one level, and then we OR the other one. So if we switch to OR, is this going to be faster? Good question. I don't know. Let's go back here. 3 equal parts. Uh-oh. Wrong button. Yep. As always, this is labeled as a hard question. Click the wrong one. Go to solution. But before we go to solution, let's try it again. So the current idea is to use OR. Let's see if this one's faster. Slightly. So that's not the main issue. All right, let's go to the solution. So update. It's actually the same. It's the same. 1116, and this is the same. I'm gonna leave as is. Leave as is. All right. Approach 1. Oh, it's only one approach. That's it. Well, so simple. All right, first we're gonna upvote, then we're gonna write LeetCode 927. To find such first element, we obtain its index and use prefix sum magic to compute the value. I'll add some. So this is for quick for O1 check. For O1 check. O1 check. For index for index I given some value, prefix sum ish array for all possible I values, first elements. Note that I is entering. Note that I, the end condition is one bigger. It's one bigger than actually allowed. Alert, alert. We need to do some rearrangement. Oh, not now? Okay. Okay, false alert. And then here, I just don't use this. There's no point, just add. I thought that's gonna be to make a difference. No, it doesn't make any difference. And then the J. Early exit. And then we can actually, I think we can save one, compute the second element, and then compare with the third, right? First and third elements can find, there is a first element equal to the third. And then, okay, so that, I think I'm going to post this, but I want to read the solution first. Each part has to have the same number of ones. Yes. It's a natural continuation of this idea. S is the number of ones in A. Since every part has the same number of ones, they should all have T equals S divided by 3. Okay. If S isn't divided by 3, the task. Oh, wow. Okay. Okay, that's pretty smart. Oh man, that's very. Oh wow, that means we can eliminate. Oh shoot. Yeah, I can eliminate a lot of situations. Let's sum it first. And this too, right? Update, add, check, add something check, add edge case, check. So check for easy edge case, easy edge case. I didn't even realize this. So we just need to say sum if sum array mod 3. Right? Return -1 -1. Yep. But it's yes. So sum array equals sum array, right? And we say if sum array is this, right? If sum array is equal to 0, return 0 and n minus 1. And I will actually put this one higher. Alright, so check for this. So 2 cases that we check. Let's see if this one runs faster. Courtesy of the official solution. Alright, so with this check, I hope that would be even faster. Go. Let's see. Let's see. Nope. 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 It's about the same. Okay, it's about the same. So that's not. Alright, that's another one. That doesn't really change the runtime too much. But it doesn't change the runtime too much. Doesn't change the runtime at all, actually. Let's just call it. It doesn't change runtime at all. All right. Okay. If it isn't divisor testing possible, we can find the positions of the first teeth, t plus 1, 2t, 2t plus 1, and 3t 1s. The positions of these ones form 3 intervals. Between them, there may be some number of zeros. The zeros after J3 must be included in each part. There is Z of them. So the first part is now this. Similarly, the second part is now this. If all this is actually possible, then the final answer is this and this. I don't understand. I read again. We can find the possible position of the first one. The t's. Oh yeah, because we have to have t1s. That's true. the t plus 1 ones, the 2t plus 1, and 3t 1. Yes, yes, because from first t to tth, there are t1s, another t1s, another t1s. Okay. I1, J1, I1, J1, I2, J2, I3, J3. Only 3 ones, and the intervals are each length of 1. That just means the intervals I and j is the same. The first is the t's. Now between them, there may be some zeros. Yeah, we have the ones and ones, ones and ones, ones and ones, right? And between them we have zeros. So the zeros after J3 must be included. That's true in each part. If there is z, then ooh, I think I got it. That is sick. That is very, very sick. So just look for that from the. It's a block of ones. If not, the block of ones, if they're not equal, like just enclosed by ones, if they're not equal, then that's a no-go. So we also find the number of zeros after power 1, 2, 3. So x, y, z, right? If x smaller, x is this. If x is smaller than z, yeah, that's no go. Y smaller than z, that's a no go. And then we return. Oh, ooh. Nice. Let's use letters as variable names. What could go wrong? Yeah, what could go wrong? I don't know. Fine. I'm fine with letters as variables. I mean, it's not like doing this for what? For like a software engineer, right? What is th? Yeah. All right. This is pretty good. Yeah. I want to post mine. Yeah, let's just post ours just for fun. What should we call it? That's how mine know. So this one I'm gonna call it prefix sum ish solution. Very interesting choice of words. Right? Very interesting choice of words. So here's what we're gonna do. Copy and paste here. Here's just a note. That's a Python. Yeah, and we keep the minimum. You know what? I don't like how I do this. I like to be more explicit. Let's just be more explicit. So no is the mid value, and then the mid value. Yeah, I like doing this way. Like, what's the point to being short if it sacrifices readability, right? I don't want to sacrifice readability. All right. All right, now let's go back here and try to code the official solution. It was very, very smart. All right, official solution. This is the official solution. Very smart. Reference. Alert. 2 minutes, okay. Oh, challenge, can we do this in 2 minutes? I don't think so. Okay, so what do? Okay, we first do a check. Like, I mean, we can include the check no matter what. It's fine. So we do the check first, right? And now we have the sum, so we know how many do we expect, right? So sum array. So the first we need to have. So what are we doing? What are we doing? So we want to find the first one, and then the end of the first one, and how do we go? So we iterate through, right? If we find one, and we increment, right? We increment, and once we hit sum array, so each equals sum array divided by 3. Right? That's each. If we hit each, yeah, I have like kind of my way of doing this. So what we have now is ACC equals to 0, right? For I val in enumerate array. Accumulate equals this. Indices equals this. Right. And then for this and this, if val, then ACC plus equal 1. And then I'm going to check if ACC is equal to each. No. If ACC equal to 1, right, then indices dot append I. And keep going. Incoming! Hold on. Wait, you're not using the mittens? Oh. I'll have another chance. Incoming. Oh. Okay, I think this is good enough. Oh. Alright. Incoming has been resolved. Alright, let's keep coding. Where are we? We say if ACC is equal to 1, that means it's the first one. Then we append it. If ACC is equal to each, right? Indices dot append I as well. But after append I, we need to reset ACC to 0. Yeah, that's how we get So after we're done, we have all the indices, which is I1, J1, I2, J2, I3, J3 equals indices. I like this trick. I like this trick very much. So now we have these. What do we do next? We need to check if they are all the same, right? So we say if if array I1 to J1 plus 1 is not equal to array I2 J2 plus 1 or array I2 J2 plus 1 is not equal to array I3 J3 plus 1. Right? So we're just saying that the first not equal to the second. If they're equal, that's fine, and we check the second and the third. Right? So if any of these are not equal, then when they're returned, minus 1, 1, minus 1, minus 1. Right? If they are equal, then we need to check the zeros. Right? So the zeros. So we say 0, Z1, we have Z1 equals to I2 minus J1. I2 minus J1, minus 1. And Z2 equals I3 minus J2 minus 1. And J3 equals, actually I didn't use N at all. I only used it once. So putting here, this minus 1 minus J3. Do I have the minus 1? Yes, we do. Right? It's not J3, it's Z3. So this is number of zeros between J1 and I2. So copy here. That's going to be J2 and I3. And this is number of between J3 and the end. So we have to count the trailing zeros. We say if Z1 is equal to Z3 and Z2 is equal to Z3. So the trailings are all the same. All right. Then we can return something. What do we return? We return I3, right? Return I3, and what about the front? The front's going to be J1 plus, not J1 plus. Isn't that just I2 minus 1, right? I2 minus 1 . Yeah, I think that is the. Oh no. Hold up. They don't have to be the same. No. They don't have to be the same. Because I can just get, it won't fail if Z1 is smaller than Z3 or Z2 is smaller than Z3. Right? If they're smaller, then it's impossible to fit. That's why we say when they return minus 1, minus 1. That's an impossible case. Now if they're the same, right? If they're the same, then we can return. This is going to be J3, no matter what, right? No, not J3, I3. I3 is for certain, all right? So the question is just where do we, it's actually not I3. We have to play around, right? We have to play around. So for the first one, right? For the first one, we can start at J1 plus Z3 because we have to do Z3, right? That much. Yeah, so J1 plus Z3, that's for sure. And the third one has to make sure that the second one has the same amount of zeros as the third one, which means it's going to be J2 plus Z3 plus 1, right? J2 plus the number of zeros, then plus 1. Yeah. Let's check, see if our implementation is correct. What do you think? Boom! Not enough values to unpack. Oh, and also undefined name. All right, there's a lot of issues. I thought I didn't use this. And never mind, because this one we can just do. All right. So indices is not right. Why? Why would it not be correct? We go through every single one. We do 2 at a time. Oh, I see. If. Okay. We have -1. That is not right. Where does -1 come from? Dios mío, -1. The heck? Okay, calm down and let's take a look. Let's first check the indices. So, comment out everybody else. Let's check the indices. Let's just print indices, see what do we have. I'd expect to be 0, 0, 2, 2, and 4, 4. That is correct. That is correct. And we must pass this as well. Yeah, we must pass this as well. Otherwise, we won't be able to get to the 2, right? So it's this thing. I2 is here. Minus J1 is here. All right? And -1. That's the number of zeros. I3 minus. I think these are all. Okay, so let's just print it out. Z1, Z2, and Z3. It should be 1, 1, 1. Ooh, that is not correct. Yeah, let's see. I think it's len array. It's not len array -1. Because it's the next one, so it has to be len array. Now we pass. Now we check. Now we pass. Oh, this is vastly simpler than my solution. I have to have a mental map in the head. Yeah, it's len. There's this, and then return this. Good Lord, that's a good question. Very good question. More of a, I don't know. This solution is more IQ test, which is very smart. Oh, look at that! Look at that! 352. Very fast. Very, very fast. 352 milliseconds. Very good. Okay, so we posted ours, and that's it. Wow, one of the faster Saturdays. Good. All right, I'll see you guys tomorrow. Sunday, another difficult one. Adios.